Okay, chemistry and pre-AP chemistry, this is going on in the thermo notes. And so I am on at the bottom of page 2 talking about those phase diagrams. So my last video was talking about phase changes going from solid, liquid, gas. This is along that same concept. We have drawn a diagram, and a phase diagram is a graph of the pressure versus temperature. So I have pressure on my y-axis and temperature on my x-axis. And so it shows conditions which the states of matter exist. You are at a current temperature and pressure right now. And as temperature changes, we've already established that the energy changes, and so therefore the states of matter change. But also pressure has something to do with it as well. If you think about when you go like up into the mountains or into the depths of the ocean, the pressure is different and different things happen and things behave differently because of pressure. With gas, we kind of understand how pressure and temperature are related. That being said, if you're in my class, we haven't talked about gases, and we'll get to gases eventually. But for now, just trust me. So here I have lines graphed out, which I'll explain them in a little bit. But these lines are separating the states between solids and liquids. So I know a solid exists for this compound at a relatively low temperature, which fits with what we were talking about, right? As temperature increases, I go from solid to liquid to gas. And then also as pressure increases, it changes what's going to exist because that pressure is squeezing those particles, and so it would make it stay in a solid longer or go to a liquid. So that being said, each compound has a slightly different phase diagram because its molecules are made up differently, but in general these concepts are the same. So solids exist here, liquids exist here, and gases exist here. That's always what the phase diagram is going to look like. These lines might move and be more drastic, but that's still the general gist of it. This point right here is called your triple point. It's the first vocabulary word after phase diagram, and it is the point in which all three states can exist. At that exact point, whatever that temperature and pressure is, if you're at that temperature and pressure, you could have a solid, a liquid, or a gas, or you could have a mixture of all three. So very important to understand that that is where all three states can exist. Generally, you don't have triple points under normal conditions, but it still exists, so it's good to understand. Your critical point is the temperature and pressure above which a substance does not exist as either a liquid or a gas, but as a supercritical fluid. And so in this case, a critical point would be somewhere like up here. So this would be normally a critical point, which after that I wouldn't have this line right here because then they would exist as a supercritical fluid. That's when I don't have just a liquid or a gas. And then it gives you an example about carbon dioxide. And then you have your normal melting freezing points, is the point in which the solid and liquid states exist in equilibrium at standard pressure. So right here, this line is saying this is whenever something goes from a solid to a liquid, that would be melting. Whenever it goes from a liquid to a solid, that would be freezing. So these lines kind of separate those phase diagrams and those phase changes as we have talked about them. And then the same thing goes for here. This would be going from a liquid to a gas, so we'd be vaporizing, or from a gas to a liquid, we'd be condensing. And then sublimation and deposition are right there, those phase changes as well. So you can kind of see how all of those things can happen based off of this diagram, which brings us to the end of this one. And then I'm going to do a phase change diagram, which is the one that you saw in the notes where you have your line straight, line straight, line straight. We'll talk about that. Make sure we're understanding before we get into specific heat.